So we're going to continue our lesson on 14.1, and I want you to look at the two graphs that I provided for you up on the screen. And I want to know which one is sine and which one is cosine, assuming that there are no translations. Yes? A is sine. And how do you know that? Yep, sine always starts at 0, and we'll learn later on in the week about shifting the graph, but the graph at its core starts at 0. And cosine would start at the upper level. So the little markings that we kind of write out for these problems is for sine, we'd write that it starts in the middle, and then it goes to the upper, and then back to the middle, and then it goes to lower, and then back to the middle. Yes, ma'am? You don't have to write that. We're just, because it's our notes, I want you to write down whatever you need to help you remember. And then Brad told us that's cosine. So since it starts at the upper, then it travels to the middle, then it travels to the lower, back to the middle, back to the upper. So it's very sequential, very patterned. It's always going to be the same pattern. All right, so I need some help from you guys because I did a little different order in the other class, so now I can't remember. Tell me the first problem on that set of notes that we have not done yet.
8.
Number 8. Even on the front, we did everything? Yeah. Oh, we're good. All right. Number 8. So we've got 3 cosine and then a 2 theta. And I don't remember if we talked about this stuff yet. Have we ever done an example where there was a number inside with theta? Okay. Write a little note to yourself. The formula is A times cosine of B, and I'm going to put a theta there. We discussed what the A represented. Who remembers what the A represented? The amplitude. That's how high and how low the function goes. But this little guy here is going to change the length of the period. Essentially, what you have inside of the cosine function is the frequency. So the frequency tells you how many cycles you're going to be complete by the time you get to what would have been our normal cycle length, which would have been 2 pi in this case. So how many cycles are we supposed to have completed according to this function? 2. So we're going to see when we have this graph that we're going to have 2 complete cycles graphed by the time we got to 2 pi. Let's talk about what would have been the normal period for any cosine graph. The normal period was 2 pi, but because they have this 2 stuck in this equation, what you're going to do is you're going to divide the period by the b value. So what is 2 pi divided by 2? Pi. What pi means is that is the new period length. So remember, I always have you guys graph quarter points. So you're going to take the new period and you're going to divide it by what to get into quarters? 4. So we're going to mark off every pi over 4. Yes?
Are you always going to end up with pi in the period?
Not always. We're going to see some examples coming up where actually the period is like 8. It's not even a pi number at all. Okay. So what we're going to have to mark off is every pi over 4, and we're going to start at 0. So our next marking will be at 1 pi over 4. The next marking would be at 2 pi over 4. But what is 2 pi over 4? Pi over 2, good. The next marking would be at 3 pi over 4. And then the last marking we're going to do for now is 4 pi over 4. What is 4 pi over 4? Pi. And it helps me kind of organize my thoughts. This time we're going to do cosine. Where did cosine begin? Middle line or upper line? Upper line. So this will start at the upper line, and then we'll mark at middle, down to lower, back to middle, back to upper. I kind of forgot to do my favorite part. Writing in the amplitude, and you can use a highlighter or a marker to do this, remember. The amplitude is a 3. So mark off at 3 and at -3. Just kind of gives you some boundary lines, so when you're graphing this, it's not so difficult. If you don't have to write down these markings as detailed as this on your homework, but remember on your homework, you're going to eventually have to do a homework check. So you're going to have to transfer what's on your paper to my paper. And if you can't tell what the heck you graphed, it's going to be a really rough homework check. And remember, guys, these are your notes. So the more you write down, the better you are in the long run. Even if you think it's too much information for you, you don't need that many notes, you'd be surprised what you need after a weekend of not doing math. Okay, so our first point, 0, should be on the upper line. And then pi over 4, can you tell that these are counting by pi's over 4s? So pi over 4 is the midline. Pi over 2 will be the lower line. 3 pi over 4 will be the midline. Pi is the upper line. So we're going to connect these, but let's just continue the pattern. It looks like every single square, they're just continuing the cycle. So at this next box, we'll be at the midline. Yes, sir?
So you just go down. There's no x or y values.
The y values are either going to be at the upper line, the middle line, or the lower line.
So you just go from each square point.
Yeah, you just keep rotating through the cycle, basically. Yep. And now the graphing, remember, I don't graph so hot, but, oh, geez, that's getting bad already. Okay. And remember, you can always kind of use your calculator to verify that you're doing this okay. Oh, my gosh. Oh, gosh, that's supposed to be curvy. It did not turn out curvy at all. Okay, pretend. Oi. So by the time we got to 2 pi, which is right here, how many cycles did this thing go through? 2, because there's one cycle, there's the other cycle. Isn't that exactly what it told me I was going to do? Go through 2 cycles. Very good. Okay, moving on. Any questions on where numbers came from? I know this is like clear as mud right now. It's okay. We're going to have lots and lots of practice. Okay. Let's talk about number 9. 4 sine of theta divided by 2 this time. What is your b value? The number that's in with the theta. Be careful. It's a 1 over 2 or a 1/2. Very good. They write it as theta over 2 because 1/2 theta is not their proper form in trig. So as long as you understand that they're really the same thing.
So
1 over 2 theta is the same thing as theta over 2. So before I forget, I'm just going to mark off the upper and lower lines. It's at 4 for our amplitude. Let's talk about the period length. A normal sine period would be, yes ma'am?
Mine is not the right volume. Choose different values and notes.
Are you on the right page?
I have
What?
no.
Okay. Mystery solved. All right, so a sine problem would normally have a period of 2 pi. But our frequency says, how much of a cycle are we going to get through by the time we hit 2 pi? Half of a cycle. So your period length has obviously changed. So what you do is you take the period of 2 pi, and we're going to divide it by the b value. Now, be very careful. Dividing by 1/2 is really multiplying by 2 over 1. So tell me the length of the period now. It's a 4 pi. So this is my new period length. So let's talk about quarter points. This will be nice and pretty to divide by 4. What happens when you take the new period length and cut it by 4? Yeah, you're going to mark off every single pi value. So starting with 0, we're going to count 1 pi, 2 pi, 3 pi, and 4 pi. Someone remind me, please, where I'm graphing sine. Do I start on the midline or the upper line for sine? Midline. And then it goes to upper, back to midline, lower, back to midline. Remember, these are all things that can go on your foldable. What's the question? K means every, like, integral. So 1 pi, 2 pi, 3 pi. K could be any integer. Alrighty, so let's start graphing. At 0, we're on the midline. And then find pi, which should be on the upper line. 2 pi is back to the midline. 3 pi is the lower line. And 4 pi is back to the midline. Now, hopefully you can kind of continue that pattern. Looks like we're counting every 2 squares. So 5 pi should be upper, and 6 pi should be midline. Whoop. Whoop. Okay. Pretend. This looks like it's supposed to look. Okay. Now, just to verify that we're talking about what we're talking about. When I was at 2 pi, which was right here, how much of a cycle did I get through? A half of it. Is that what we were supposed to do?
Yeah.
All right, we're on track. Some little part of you likes this, doesn't it? You're not sure why. Some teensy bitsy part of you. It's graphing. And you can use your calculator, but that'd be horribly slow, so don't do that. Okay, 4 cosine 2 theta. Let's mark off the amplitude. So 4 and negative 4. There's definitely a b value in this problem. So when I get to 2 pi, which will be right here, how many cycles have I gone through, supposedly? I'm supposed to have gone through 2 cycles. So when we get done with the problem, we're going to verify that. So your b value is a 2 this time. A normal period for cosine would be 2 pi, but since I'm supposed to complete 2 of them, we're going to cut that by 2. Yes?
I'm a little confused on how the b equals 2.
It's the number that's in with the theta. So whatever's inside the cosine, whatever's in with the cosine, the number part in front of the theta is the b,
Okay.
the coefficient. All right, so our new period length is what? Pi. Whoops. So let's talk about markings. We're going to mark quarter points. So you take the new period and you divide it by 4. So we're going to mark off every single pi over 4, starting at 0. So 1 pi over 4 is pi over 4. What's 2 pi's over 4? Pi over 2. What's 3 pi's over 4? That's not exciting, 3 pi over 4. And what's 4 pi over 4? Pi. Talk to me about cosine. Cosine starts where? Upper, and down to middle, down to lower, back to middle, back to upper. Okay. 0, I should be on the upper line. Pi over 4, careful, I think he's right here, should be on the midline. Pi over 2 is lower. 3 pi over 4 is middle. And pi is upper. Now that's only 1 cycle. We obviously have more room here. So we need to continue the pattern. What? Well, whatever domain they provide you, if they give you a graph, you have to complete the entire domain of the graph. Now, when you guys do your homework, you guys are providing your own graphs. So you are in charge of marking the x-axis, which actually makes this a lot easier, because if you know your markings are going to be at pi over 4, pi over 2, 3 pi over 4, and pi, you just mark those down and draw. So it's actually, this is the very strange case of it's easier if I don't give you the graph. So, okay. Let's see how bad I can do this one. Ooh. How many cycles did you get through by the time you got to 2 pi? Let's see, 1 cycle, 2 cycle. Is that what we were supposed to do?
Yeah.
Yeah, we're good. Okay, number 11. 3 cosine theta over 2. So tell me, what is the b value in this graph? It's a 1/2. So let's go ahead and mark our amplitude of 3 before I forget again. Cosine normally has a period of 2 pi, but we need to divide it by the b value, which in our case is a 1/2. Think about what it means when you divide by a 1/2. You're really multiplying by the reciprocal. So what is the new period? 4 pi is our new period. So take the 4 pi, cut it into quarter points. We're going to mark off every pi. Quarter points. The cycle has 4 distinct points, so we always divide the period by 4. No, the number in front of the cosine tells you your amplitude, how high and how low you're going to go. It's always quarter points, Josh. So 0, and then 1 pi, and then 2 pi, and then 3 pi, and then 4 pi. The reason we do quarter points is because when I start to go through the cycle of upper, middle, lower, middle, upper, it's always 4. It's always in sequence of 4. That's why we always divide by 4. So cosine should start at the upper, go to middle, go to lower, middle, upper. All right, so at 0, we're upper. We're not going to do tangent. Tangent's no fun. Tangent looks very weird. If you graph tangent on your calculator, you'll see what he looks like, and he's not normal. Yeah. Oi. By the time I got to pi over 2, which is right here, how much of a cycle did I get through? A half of one. Makes sense. Okay, good. The question was, what does tangent look like? I'm going to skip this guy for a second, but just so we're all clear, the period would have been 8 pi. You guys comfortable with that? 2 divided by 1/4 is 8, because it's 2 times 4. And then your quarter points would have been every 2 pi, so you would have marked every group of 2 pi. Okay, but the question was, what does tangent look like? Tangent, my friends, looks like this. So he's got a period length of pi, actually, and he squiggles through the origin. So if I just graphed a normal tangent, he looks like this. And then he would do another one of these squiggles over here, and he'd continue on doing squiggles for the rest of his life. Do you notice what tangent has? What are these called? Vertical asymptotes. When you go to trig, you'll learn more about why he has vertical asymptotes. It's a fun time for trig. We'll save it for trig. But you guys never have to graph tangent for this class, so don't worry about it. Okay, I really need you guys to get your 14.1 homework done tonight. We're going to start 14.2 tomorrow. And 14.2 is going to require that you really understand 14.1. Okay? So please do that tonight.